Today is May 8th, and we're going to talk about inverse trig functions today. And the assignment's going to be worksheet TEI, that stands for trig, trigonometric equations and identities, and -1, okay? All right, so this is the graph of y equals sine x, okay? And what I want you to understand is that this x represents an angle that we rotate around the unit circle, okay? So this x is an angle. So the input is an angle, and what we get out here is a ratio. And for the sine function, it's the ratio of the y coordinate over the radius, right? Okay. All right, so if you look at this graph, okay, we have the domain. The domain is negative infinity to positive infinity, okay? So we can put any angle of rotation in here, okay? Any size angle, all right? And what we get out for the ratio, okay, we're limited to what we get out. The range is the smallest the ratio can get is -1, and the biggest the ratio can get of y over r is +1, okay? So that means the range is -1 to 1, okay? Now, from 0 to pi over 2, this is quadrant 1. Pi over 2 to pi, that's quadrant 2. Okay, that's the upper left quadrant. Pi to 3 pi over 2, that's quadrant 3. And 3 pi over 2 to 2 pi is quadrant 4. Okay, so this is quadrant 4 right here. But 0 to, or negative pi over 2 to 0, okay, this is also quadrant 4. Negative pi over 2 to negative pi, remember we're going with a clockwise rotation, right? This would be quadrant 3 right in here. This would be quadrant 2, negative pi to negative 3 pi over 2. And then between -2 pi and -3 pi over 2 would be quadrant number 1. Okay, so this is the first quadrant. And that's why this mimics the first quadrant right here, right? They're the same because the ratios will be the same because it's putting it into the same quadrant, okay? Now, we want to talk about the inverse of it, okay? So remember from inverses, okay, from a few months ago, right? If we want to graph the inverse of this, we just swap the x and the y, okay? So this x is now the angle, and y is the, sorry, take that back. Y is now the angle, and x is the ratio, okay? So here we put in an angle, we get out a ratio. Here, okay, y is the angle still. Y now is the angle. And this x is now the ratio, right? Because they switch, okay? And if you look at this, okay, its domain would be -1 to 1. Remember, they switch, right? So the domain is now -1 to 1 because the inputs are anywhere between -1 and 1, okay? And the range is now going to be negative infinity to positive infinity. Okay. Now, this right here, I'm going to come back so we can come off a little bit. This from 0 to pi over 2, this is quadrant 1. From pi over 2 to pi, this is quadrant 2. Okay. And then pi to 3 pi over 2, this is quadrant 3. I wrote 4 right there, right? Well, not even 4 in Roman numerals. So this is quadrant 3. And then 3 pi over 2 to 2 pi is quadrant 4, right? Okay. And then going down this way, okay, negative pi over 2 to pi, this is quadrant 4. Negative pi over 2 to negative pi is quadrant 3. Negative pi to -3 pi over 2 is quadrant 2. And -3 pi over 2 to -2 pi is quadrant 1. Okay? Now, there's a problem with this in that if we write x equals sine of y, okay, that's not a function, right? Because if we like choose, okay, let's say that we put in the ratio of 1, right? We put a ratio in 1. Well, the angle could be pi over 2, or it could be negative 3 pi over 2. You see this? Okay, so it could be either place. So we need to restrict this so we keep the same um, um, so we keep the same domain. We want it to be negative 1 to 1. Why? Because over here, we have negative 1 to 1 for a range, right? And those are all the ratios. So we want to be able to put in all of the ratios, and all the ratios would be from negative 1 to positive 1, but we want to restrict what we get out, okay? So what we do is we limit this, okay? So what we do is we start it right here, and we want as close to the origin as we can. Okay, so right here, we're going to start at negative 1 here, and we're going to include all of the values until right here. And basically what we're going to do is we're going to cut out all of this part of the graph and all of this part of the graph. And so we're going to be left with just this part, okay? And then what that's going to do is it gives us an inverse function, okay, where we can put any ratio in between negative 1 and 1, and we will only get one angle out, okay? So what that looks like is this, okay? So let me highlight this. So we are going to only use, I'm going to do this in green so you can see it. We're only going to use this part of the graph. And by limiting the range here, okay, we are going to be limiting the domain on this one, okay? So basically what we're doing is we're cutting this part out of this graph and this part out of this graph, and we're only looking at this part, and we're doing the inverse. We're doing this with only that part, okay? And that's called sine inverse of x, okay? So the graph is going to look something like this, okay? So right here at negative 1, so at negative pi over 2, it's going to be at negative 1. And then at 1, it's going to be at pi over 2. And it's going to go through 0, 0, but it's not a straight line, okay? Because this is going to be sideways, okay? So it's going to come like this and then come up like that, okay? And so this is the graph of sine inverse of x. Now there's another name for it, arc sine of x. So you see this this is interchangeable, okay? So sometimes you'll see sine inverse of x, and sometimes you see it called arc sine of x, okay? So for this inverse function for sine, okay, it's now the domain is negative 1 to 1. So we can put any ratio between negative 1 and 1 in. That's all the ratios that could possibly happen for sine, okay? And we get out a range between negative pi over 2 and pi over 2. Okay, so we put in one of these ratios, and we're going to get out an angle between negative pi over 2 and pi over 2, okay? Which means, okay, remember this from 0 to pi over 2 is quadrant 1. Okay, that describes quadrant 1. Angle 0 to pi over 2 is quadrant 1. Well, that's where the ratio is going to be positive. And this part right here is quadrant 4. So negative pi over 2 to 0 is quadrant 4. That's that bottom right quadrant. Why do we need that bottom right quadrant? Okay, we need that bottom right quadrant for when the ratio is negative. Okay, so what we have is we have y is equal to sine inverse of x. And what we have to realize is that this x is a ratio. So this is the ratio of on that angle of rotation of y over r. And this y now is the angle. And we're limited to what angle can be, okay? So once again, the domain on this is negative 1 to 1. And the range, again, I'm going to write this again, is negative pi over 2 to pi over 2, including, okay? So I'm going to draw a little diagram for you. When we draw our terminal side of our angle of rotation, right, and we draw it into the first quadrant, okay, we're going to use this first quadrant, okay, when the ratio is positive. When the sine ratio is positive, and we're trying to find an inverse trig function, this is going to be a positive angle. And it's going to be some angle between 0 and pi over 2, okay? We're going to have to come down here. We're going to have to rotate with a negative angle into the fourth quadrant. And when, I know this is hard to understand right now, okay? It will get easier as we do problems, I think, okay? That's usually what happens, okay? Because right now you're like, what the heck? And I get it. It's normal to feel that way, okay? Just so you take comfort in that's normal, okay? So when down here, we're gonna have to come down here. If this ratio that we're putting into sine inverse were negative and we're looking at sine inverse, we have to rotate down into this fourth quadrant. Why? Because here is where the ratio is going to be negative, okay? So all the time, the sine ratio of y over r, it's going to be negative in this quadrant, okay? So we're going to write ratio, the ratio is negative. Okay, now we can't rotate all the way around because of the way the graph looks, okay? We have to rotate down with a negative angle. Okay, so we're limited. We can't come this way because that would be a positive. I'm sorry, that would be a negative angle, right? And it'd be a positive angle. I said the wrong thing. So we'd have to go bigger than pi over 2 to get over here into here, right? And our range says you can't. Okay, so we're limited to negative pi over 2 to pi over 2. So we're limited to this region, okay? So we're going to come down this way. And so we would get out a negative angle. So if we have a negative ratio and we're trying to find sine inverse of that, the only way to do that is to come down and the answer would be a negative angle, okay? If our ratio is positive, we're gonna have a positive angle and that positive angle will be between 0 and pi over 2. If we have a negative ratio, we're gonna have a negative angle and it's gonna be between negative pi over 2 and 0. It's gonna be somewhere in here, okay? And that creates it to be, remember one-to-one functions? This creates a one-to-one function, and then the inverse is itself a function, okay? So we all will get the same values out, okay? So here's the problem. If we do something like, like up here, if we were using this entire graph and I said, okay, what's the ratio for -1? Okay, so what angle would give you a ratio of -1? Well, we would all come out with different answers. Okay, some of us would say negative pi over 2. Some of us would say 3 pi over 2. Well, which one's right? Well, both are right, right? So we need to get one answer. So we all get the same exact answer and we all get only one answer. Okay, that's what this is for. We all get the same answer and it's one answer for this one problem. Okay, because we've restricted the domain. Okay, remember restricting the domain on all that when we did that with parabolas. Okay, and we also did it with absolute value functions. Okay, all right. Okay, guys, let's go to the next one. Okay, I know this is going to be a long lesson in the explanation. The problems don't take that long. Okay, but the explanation does take a while. Okay, so let's go to the next explanation. There's actually 6 inverse trig functions. We're only going to study 3 of them: sine inverse, cosine inverse, and tan inverse. Okay, and in all honesty, those are the only 3 you really need to know. Okay, all right. The other 3, the secant inverse, cosecant inverse, and cotangent inverse, just really aren't used that much. Okay, so there's actually conversion formulas, and if you know sine inverse, cosine inverse, and tan inverse, you can use those to figure out the other ones. Okay, all right. So now we're going to look at cosine x and the inverse of cosine x, okay? So again, this x right here for cosine is an angle of rotation, and this y is the ratio. Okay, so now the ratio that we're looking at is the x coordinate over the radius of the point moving along the circle, right? For that unit circle. Okay, now when we do this, okay, now this is going to be, the y is now going to be the angle. We switch the x and y, right? This y is now going to be the angle, and this x is the ratio. Okay, for y equals cosine x, the domain would be negative infinity to positive infinity. And the range is the smallest the ratio we can get is -1, and the biggest the ratio could be is +1. So the range is -1 to 1. Okay, so over here, they're going to flip-flop, right? So now the domain is going to be -1 to 1. And the range is going to be negative infinity to positive infinity. There's a problem with this though, right? This is not a function. Okay, so if we just switch these, right, it's not a function, right? Because if I pick like a ratio of 1, okay, or let's say ratio of 0. Let's say 0, okay? So some of us are going to give us an answer of -pi/2. Some of us are going to give us an answer of pi/2. Some of us are going to get an answer of 3pi/2. Some of us are going to give an answer of -3pi/2. Well, which one's the right answer? We need one answer, right? For an angle of a ratio of 0, which of these angles is it? So we're going to limit this, okay? And we still need the whole, we need to be able to put in every single ratio between -1 and 1. So what we're going to have to do is we're going to have to restrict this range, okay? And the way we restrict the range, keeping the domain -1 to 1, is we're going to throw out all of this part right here. And then we're also going to throw out all of this part. Okay, so we're left with -1 to 1. Okay, and look what happens. Okay, so if I give you 0 now, if I only use this part of it, right? Okay, let me highlight that with green. Okay, if I only use this part of the entire graph to say that's going to be the inverse function, look, if I say, okay, so what's the angle when the ratio is 0, and reading off the graph, oh, it's going to be pi/2, and we'll all get the same answer. You see? And what if the ratio is -1? What angle will give you a ratio of -1 if we do the inverse? Well, ratio of -1, oh, it's going to be pi. Okay? Now, this is what's important. Okay? Right here, so we're only talking about this part right here. We're talking about angle 0 to pi/2, right? That describes quadrant 1. And then pi/2 to pi, that's quadrant 2. Which means if we're only using quadrant 1 and quadrant 2, that the answer to this is always going to be a positive angle. Okay? Now, why would we need to rotate into the first quadrant? Well, we need to rotate into the first quadrant because that's where our ratio of x over r is going to be positive. We would need to keep rotating in the positive direction for angles pi/2 to pi, and we need to rotate into the second quadrant when our ratio is negative, because these are our ratios, right? And look, quadrant 2 is the angle here, okay? And that's when we're going to have a negative ratio. So we're going to need quadrant 2 when we have a negative ratio. And we're going to need quadrant 1 when we have a positive ratio. And to be honest with you, we always want to use quadrant 1. All of these are going to use quadrant 1. Why? Because we're going to use quadrant 1 when that ratio is positive, okay? And then sometimes we're going to rotate into the second quadrant. And then sometimes we're going to have to rotate into the fourth quadrant. And we're going to have to rotate into the fourth quadrant when when the ratio is going to be negative for some of these, okay? Now, why don't we want to rotate into the fourth quadrant here? Well, if we rotate into the fourth quadrant right here, right, look, the ratio is still positive. This is the ratio right here, right? And the ratio is still positive, okay? This will make more and more sense, okay? Again, you're probably like, what? It's okay. It's okay. All right? I get it. I get it. Okay, so what does the graph of y equals cosine inverse of x, or we also call it our cosine, look like? Well, it looks like this. It's this green part, okay? So it starts at -1, it starts at pi. At pi over 2, it's 0. And then at angle 0, it's at 1. So it looks like this. This is the graph, okay, of cosine inverse. And right here we have vertical tangents, okay? That might not be something you know. That I just realized I'm talking calculus there. Okay, don't worry about vertical tangents, okay? Okay. So, what's the domain for this? Okay, so we need the domain. The domain is the input, and that's the ratios. Okay, so this is a ratio. Okay, and we get out an angle. Okay, so that means for this, we need, because for the cosine ratio, we can have any ratio between -1 and 1. That's why we need to go between -1 and 1. So our domain is -1 to 1, and our range is 0 to pi. So angle 0 to pi, it's right in here, right? So 0 to pi over 2, that's the first quadrant. Pi over 2 to pi, that's quadrant 2, okay? So I'm going to draw this in. This is quadrant 1, and this is quadrant 2. And if we need to rotate, we just keep rotating in a positive direction, okay? Into the second quadrant, okay? All right, so let's write this. Okay, so y equals cosine inverse of x. And that little -1, that's not an exponent. That's just the symbol we use for inverse, okay? Again, the domain is -1 to 1. And the range is 0 to pi. So we're always going to get a positive angle out of this. Because notice we don't get any negative angles, right? Because we can only choose an angle between 0 and pi. Okay, so I'm going to draw a diagram to help us understand this a little bit better. Okay, and remember, let me write this in red. Again, this x is a ratio, and this y is an angle. Okay, so if this ratio, if I'm saying what's cosine inverse of the square root of 3 over 2? Square root of 3 over 2 is a ratio, right? And it's positive, okay? So if that ratio is positive, that's when we need this first quadrant. Okay, so here's my terminal side right here. Okay, so I know that if right here, my ratio of x to r is going to be positive. Okay, so the ratio is positive. I'm just going to put a little positive sign. And then we would rotate into here, into this first quadrant. And the angle we get out is an angle between 0 and pi over 2. And it would be a positive angle, okay? And then be between 0 and pi over 2, okay? Now, we could also come out with a ratio that's negative. And over here, remember this is the point x comma y, and this is the point x comma y. Over here, this x is going to be negative, right? And if we do the ratio of x over r, that's going to be a negative ratio. So we need this quadrant, okay, when the ratio is negative. And to get to this angle right here, we would have to keep rotating past pi over 2. So you see, we would still have a positive angle because of the rotation, right? The direction we're rotating. The angle for this negative ratio will be something between pi over 2 and pi. Okay, so that this y that we would get out is going to be an angle. If the ratio is negative, it's going to be an angle between pi over 2 and pi. Okay, so let me just do this. Okay, so if we do cosine inverse, and we're going to do this in just a little bit. Okay, if we do cosine inverse of the square root of 3 over 2, okay, that's a ratio, and I know my ratio is positive, okay, and so I would know my answer is going to be in quadrant 1. Okay, if I did this cosine inverse of, let's say, negative square root of 3 over 2, okay, so now my negatives are, okay, I can't be in quadrant 1 because in quadrant 1, my x and my r are both positive, right? And so here my x has to be negative. Well, the only way to do that is to rotate all the way into quadrant 2. So I'd have to find my angle in quadrant 2. So this one is in quadrant 2. And so we would get, for this one, we'd get an angle between, let's just write, angle is between 0 and pi over 2. And for this one, our angle is between pi over 2 and pi. Okay. Hey, let's do this. I just realized, let's do this and let's go back to the first page. Okay, let's do this with the sine inverse one. Okay, I think that might help us out a little bit. Okay, I wish I could see your faces. You guys, I really rely on reading your faces and seeing if you're getting it or not. And this is so hard, okay, because I can't read your faces. Okay, like I wish I could just see you guys. Okay, but I can't. To be safe, we can't see each other right now. Okay, let's go back to the first page. Okay, so let's talk about this. Okay, so let's say we took sine inverse of the square root of 3 over 2, same ratio as before, right? Okay, so the sine inverse of square root of 3 over 2, that's a positive ratio, right? The ratio is positive. I'm gonna have to rotate into the first quadrant. Okay, so the answer to this is in quadrant 1. Okay, which would mean the angle would be between 0 and pi over 2 because I'm rotating positive into quadrant 1. Okay, so the angle is between 0 and pi over 2. Okay, what if we did sine inverse of negative square root of 3 over 2? Okay, so now I can't be in the first quadrant because my ratio is negative, and because this is the ratio of y over r. Okay, and if I go into the first quadrant, y is positive and r is positive, I couldn't get this negative ratio, right? There's no way to rotate into the first quadrant and get a negative ratio because x, y, and r are all positive in this first quadrant. Okay, all right. Some of you might be wondering, well, why can't you go over here into the third quadrant or something like that? Well, it's because of the way the graph is, right? Okay, so we have to get this negative ratio, the simplest way to do it is to just go without any breaks in the graph. We really don't want any breaks in these graphs, okay? So what we want to do is we can get a negative ratio if we rotate down, okay, into the fourth quadrant, because in this fourth quadrant, our y is going to be negative, right? But to rotate into the fourth quadrant, I have to go down with a negative angle. Okay, so I have to rotate in the opposite direction, basically, okay? So this would have to be, this is in quadrant 4. Okay, so our angle has to be negative, okay? So because our angle is because we're rotating clockwise, our angle's negative, right? So it's going to be between negative pi over 2 and 0, which would give you a negative angle, right? Negative pi over 2 to 0 is a negative angle, okay? All right, guys. Okay, let's do one more to the explanation of this, and it's tan inverse, okay? So let's go to the third page, okay? So skip 2 pages ahead, and we'll go to that one. Okay, so for y equals tan x, okay, this x, again, for all the trig functions, we put an angle, and we get out a ratio. Okay, so for this one, I'm not gonna write the domain, okay, because there's a lot of breaks in this, okay. So I'm just gonna say domain, and I'm not gonna worry about it right now, okay, because that's not the point of this, okay. But you have to go negative 3 pi over 2 to pi over 2 to negative pi over 2. I'm sorry, and then negative pi over 2 to pi over 2 union pi over 2 to 3 pi over 2 union 3 pi over 2 to 5 pi over 2 union 5 pi over. Like you'd be sitting here writing them forever, okay. What's important here is the range. Okay, so what are we getting out? Okay, so what we're getting out, okay, is anything between negative infinity and positive infinity, right? So our ratio can be any number. So negative infinity to positive infinity, okay? So now we're gonna graph x equals tan y, okay? Now, because it's tangent, this y is now the angle, and the x is the ratio. Okay, so x is the ratio. The ratio we can get out is anything between negative infinity and positive infinity, right? Okay, so the domain for this one, remember they switch, right? So the domain is negative infinity to positive infinity, okay? And the range, I'm gonna not write, okay? Because it's an infinite, it's infinite number of intervals, okay? So we're not gonna bother writing that, okay? So we want our function to be continuous, okay, which means there's no breaks in the graph, okay. So right now, like if I said, okay, so what's the angle when the ratio is 4, right? So when the ratio is 4, we could have it as that angle, we could have it as that angle, we could have this angle, we could come straight down. It could be, so there's 4 different angles. If the ratio is 4, there's 4 different angles that cause a ratio of 4, right? So we only want one of them, okay? And we want to use quadrant 1. So we want to use this quadrant right here, right? From 0 to pi over 2, we want to use that quadrant. So we're going to want to only use this part of the graph, okay? So that means we are going to cut out this part, and we're going to cut out this part, and we're going to cut out this part, and we're going to cut out that part. And the way we cut that out is we say the range. The range is only this, okay? All right. So we are only going to use, and I'll use my green. We're only going to use this part of the graph. Okay. So down here, now notice these had vertical asymptotes, right? So when we switch the X's and the Y's, right, those vertical asymptotes become horizontal asymptotes, okay? So I need to draw horizontal asymptotes. So we're gonna graph this green part on this grid, okay? So I'm gonna grab my ruler, and where's the vertical asymptotes were at negative pi over 2 and pi over 2, okay? So basically I'm cutting this part out, right? I'm actually restricting the domain here, which causes the range to be restricted, okay? So what I'm going to do is these vertical asymptotes at negative pi over 2 to pi over 2, okay, those are going to become horizontal ones. So I'm grabbing my ruler. So I'm going to draw one at pi over 2. And then negative pi over 2. This is the last one we're going to talk about too. For a minute here, I got worried I wasn't recording. This is going to be a long lesson, okay, guys? I'm sorry. I'm sorry. Okay, so what happens is to graph the shape, okay, it's going to go through 0, 0. Okay, so we come along here and we just go through that. Okay, and I want to make something clear, okay? Notice down here, our ratios are negative, right? All of these numbers on the x-axis are ratios. Our ratio is negative. Look what our angle is, right? Our angle is going to be negative, right? So that's going to be the fourth quadrant again, right? And then over here, when I graph this, this is going to describe the first quadrant, right? So it's going to come up and go along here like this. So this is where the ratio is positive, right? All of these are positive ratios, but what's this angle here? Well, this is in the first quadrant, right? So that's going to be, we're going to have a positive angle. So a positive ratio, positive angle, okay? Now notice we can never get to pi over 2. There's a vertical asymptote there, or not vertical, horizontal asymptote there. There's also a horizontal asymptote at negative pi over 2. So this never actually reaches negative pi over 2, and this side never reaches pi over 2, okay? So it's important you know the graph of this, okay? That's one of the things, if we were in class, I would test you on this, and I'd say graph tan inverse, okay? Graph sine inverse and graph cosine inverse, okay? Those are some graphs that we need to know, okay? Okay, so let's say, okay, so again, this right here from 0 to pi over 2 is quadrant 1, and we always, in all of these, we use quadrant 1, and we use quadrant 1 because that's where all of these ratios are positive, okay? And then sometimes for cosine inverse, we need quadrant 2 to get the negative ratio. For sine inverse and tan inverse, we need quadrant 4 to get the negative ratio. So this is quadrant 4. Okay. Hopefully this is kind of starting to make a little bit of sense to you, okay? So we have y is equal to tan inverse of x, okay? So you got to realize that when it's tan inverse, okay, this right here, this x, this input is a ratio, and we get out an angle. And the angle we get out depends on what the ratio is. If the ratio is positive, we're going to get an angle between 0 and pi over 2. If this ratio is negative, we're going to get an angle between negative pi over 2 and 0, which would be a negative angle, okay? So looking at this, this is similar to sine inverse, okay? So right here, we have an x coordinate and a y coordinate on this terminal side, right? And if we did the ratio for the tan ratio, which is this y coordinate over this x coordinate, right? We would have to get a positive ratio, right? So, and to get to this location, we'd have to rotate with a positive angle. Okay, so we have a positive ratio. And we would have a positive angle. So anytime, okay, so for all of these, if you have a positive ratio, you're always going to have a positive angle. And you're always going to have an angle between 0 and pi over 2 if the ratio is positive, okay? Now, the problem comes in is when the ratio is negative, okay? When the ratio is negative for tan inverse, okay, because of this graph and the way we restricted it, it has to be an angle between negative pi over 2 and 0, right? Which means I can't keep rotating in a positive direction. I have to do a different rotation, right? I'm going to have to rotate in the clockwise in a negative direction, okay, for the angle. Okay, so why? So here's my other terminal side, right? That could happen. Okay, so here's an x and a y. Now, what do I know about this y? Well, because I'm down here, this y is negative. So and this x is positive. So when I do the ratio of y over x, that's going to give me a negative ratio. That's why I need this quadrant, okay? So I'm going to use this quadrant when I have a negative ratio, okay? Okay. And so we're going to have to rotate this direction. And it has to do with how we restricted the range. Really, that's what it has to do with. Okay. This has to be a negative angle because we're rotating clockwise, right? And a negative, sorry, rotating clockwise is always a negative angle. Okay, so what if I ask you tan inverse of 1 over the square root of 3? Okay, my ratio is positive, right? And if I have a positive ratio and I'm doing tan inverse, I have to only be in one quadrant, and that's this quadrant, right? So I know this is in quadrant 1. And so my angle is between 0 and pi over 2. Okay. But if I ask you, what is tan inverse? And I'm going to go over how to find the exact angle in just a minute. Okay. But right now, I just want you to know, okay, I'm in the first quadrant and I know the answer to this is between 0 and pi over 2. We're going to draw diagrams. And I don't know if you realize this, those are sides of a special right triangle, right? And because they're sides of a special right triangle, we're going to be able to get the angle. Okay. That's the idea behind this. Okay. Okay. So what if we have negative 1 over the square root of 3? Well, that's a negative ratio, right? Okay, so we have to rotate to get this negative ratio. We have to rotate down into the fourth quadrant, and we have to go clockwise, okay? So this is in quadrant 4, okay? So I know the angle I get out of this is between negative pi over 2 and 0. And if it's between negative pi over 2 and 0, it would have to be a negative angle. Okay? All right, guys. I want to say something to you guys because this comes up in calculus. So I'm not going to ask you questions like this, okay? But a lot of times they'll ask you questions. It's a limit statement, okay? So if you, what my point of this is, if you know the graph of this, you could answer this question, okay? So a lot of times they'll ask you, okay, find the limit in calculus, okay? The limit as x approaches infinity of tan inverse of x. And what does that equal, okay? So remember, this is in behavior, right? Okay, so if you know the graph of tan inverse, you can answer this just automatically, okay? So what happens as x goes to infinity, right? What are the y's doing? Well, they're getting closer and closer to what value? Pi over 2. The answer to this is pi over 2. I could also ask you, what's the limit as x approaches negative infinity of tan inverse of x? Okay, so that's going to the left, right? As we go to the left, the outputs are getting closer and closer and closer to negative pi over 2, and that'd be the answer to this one. And so see, if you know some of these graphs, you can just answer these limit questions really easily, okay? All right, so that's one of the reasons we need to know the graphs of these, okay? Because if you know the graphs, you can answer questions because you know the behavior, okay? All right, okay, so let's do some problems like this now, okay? And that's what we're gonna do next, okay? And I think once we start doing these problems, everything will start sliding in together and starting to understand what's going on, okay? Okay, so I'm going to do 6 examples here without using a calculator. Find the value of the expression in radians. So all of these are going to be in radians, okay? All right, so I'm looking at this, okay? I'm doing cosine inverse of the square root of 3 over 2, okay? And I know because it's cosine inverse, this is my x and this is my r, and I know my ratio is positive, okay? So for cosine inverse, I'm going to draw a diagram like we've been doing. This is similar to solving those simple trig functions, trig equations. It's similar to that, except for there I got 2 answers, right? Here you're only going to get 1 answer, okay? So solving equations, we can get more than 1 answer. Okay, when we do these inverse trig functions, you're only going to get 1 answer, okay? All right, so for this, okay, I know my ratio is positive. And for cosine, I'm going to rotate into this first quadrant if the ratio is positive, and ours is, right? So I'm going to rotate here. but I want to go over, okay, when would I rotate into here? Well, I'd want to rotate into the second quadrant, right? If this ratio were negative, I'd want to go over here because over here, the cosine ratio is negative, okay? My ratio is positive. So I'm going to draw this. I'm going to draw my right triangle, okay? Because of this ratio, I know this right here, this horizontal leg is the square root of 3. And I know this radius because cosine is x over r, right? This is my x, and this is my r. And those are two sides of a special right triangle. So you should know this side is going to be 1. And what angle is always opposite 1? Well, it's pi over 6, right? Okay, so my angle that I have to rotate is this one right here, right? And I have to rotate into the first quadrant, right? So what's the angle of rotation? It's pi over 6. Okay, the answer to this is pi over 6. That's what we have to do, okay? So this one now is negative, right? Okay, and because it's cosine, I'm not going to rotate down here into the fourth quadrant for cosine. Why? When the ratio is negative. Why? The ratio is still positive, right? That's why I need to rotate into the second quadrant, and I'm just going to keep going with a positive angle, okay? So for this one, okay, I know, okay, my ratio is negative. I would only rotate into this first quadrant when my ratio is positive. My ratio is not positive, okay? So I'm gonna have to rotate into here because for cosine, if I rotate into the second quadrant, if I just keep going, I will get a negative ratio, okay? Hopefully this is starting to make sense, okay? So there's my point that's the point that's on the circle that I'm going around, okay? So I'm gonna drop a vertical leg here. Here's my right angle, okay? I know that this would have to be negative square root of 3, okay? Because this is my radius, and my radius always has to be positive, so that's 2. This would have to be 1, okay? This angle right here is pi over 6. Now, I've got to get the angle of rotation, and the angle of rotation, cosine inverse has to be between 0 and pi, right? So between 0 and pi. So it's got to be a positive angle, and I'm going to stop it right there, okay? If I go all the way to here, that's angle pi, or 6 pi over 6. I've got to back up again, right? So this would be 5 pi over 6, okay? So this angle right here is 5 pi over 6, and that's the answer to this. So cosine inverse of negative square root of 3 over 2 is 5 pi over 6. Okay, now this one you don't recognize, or maybe you do because you've done it so much, right? Square root of 2 over 2 has been simplified. Okay, so what is the unsimplified version of this? So we should start to realize, oh, this came from being negative 1 over the square root of 2. Because we don't have a special right triangle that is square root of 2. One of the legs is square root of 2, and one of the sides is square root of 2, and one of the sides is 2. We don't have that. We have it where one of the sides is square root of 3 and 2, but not square root of 2 and 2, okay? And that's because this came from sine inverse of negative 1 over the square root of 2. If you simplify this, you get this one, right? Okay? And now we can realize, okay, so right now, okay, our ratio is negative. If I rotate into this first quadrant, okay, I would want to rotate into this first quadrant only if this ratio was positive, right? Because X, Y, and R are all positive in this quadrant, okay? So how do I do it when it's negative, right? So I can't, like cosine, I can't rotate into here because the ratio is still positive over here, right? So the way to do it is to get down here into this fourth quadrant, okay? So in this fourth quadrant, my Y's are gonna be negative, but the only way to do that is to rotate with a negative angle, okay? So right here, I know, okay, that's my X and my Y right here, okay? This is my R, okay? I'm gonna drop my vertical leg here, okay? So I know that from the sine ratio that the top number is my Y, or my vertical leg here, right? So that's gonna be negative 1. And this is telling me my R is the square root of 2. This leg right here would have to be positive 1. The reference angle is pi over 6. Not pi over 6. Whoa. Not pi over 6. No. Not pi over 6. Hopefully you're laughing right now. it would be what? Pi over 4. Okay. Now, my reference angle is pi over 4. That's not my angle of rotation. My angle of rotation is this direction. So it is pi over 4, but it's in that direction. So what's that direction? Well, that's a negative rotation, right? So my answer to this is not pi over 4, but negative pi over 4. Because a rotation of negative pi over 4 would put you into the fourth quadrant, okay? So when this sine ratio is negative, we're going to get negative angles every single time, okay? All right. Okay, how about this one? Okay, so basically for sine inverse, I'm limited to this quadrant with a positive angle or the fourth quadrant with a negative angle, okay? Tan, same ones, except for I can't hit pi over 2 and negative pi over 2. Okay, that's the only difference, okay? For cosine, I have to use this quadrant and this quadrant to get it, okay? So you're limiting the quadrants you can use on these, okay? All right, one is a ratio, okay? So sine inverse of 1. Sine inverse of 1 really means sine inverse of 1 over 1. Okay, so where is that going to happen? So I'm going to draw a diagram. Where is y 1 and r also 1? And in here, it's not going to happen right in here, and it's not going to happen down in here. Our ratio is positive, right? So we're going to start to rotate into this first quadrant. Y is 1 and r is 1 only at this point right here. So right there, our x is 0, our y is 1, and our r is also 1 because it's on the positive y-axis, okay? All right, so what's this angle? Now, it's a positive ratio, right? So I'm going to have to rotate with a positive angle to right there. And what is that angle? Well, this is equal to pi over 2. Okay, so sine inverse of 1 is pi over 2. We always only get one answer, and we all get the same answer. That's the whole idea behind restricting the range, okay? Okay, let's do these last two. Okay, so this is sine inverse. Okay, so what's underneath here, right? This needs to be a ratio, right? This would be 0 over 1. Okay, so where is sine inverse 0 over 1? Where is y 0 and r 1? That's the question you have to ask yourself. Where is y 0? Well, you have this quadrant if the ratio is positive. You have this quadrant if the ratio is negative. Well, what if the ratio is 0, right? It would land right here. Okay, and what's your x there? Well, your x would be 1, your y would be 0, and your r would be 1. Okay, so what's this angle? Well, we didn't rotate at all, right? So this angle is 0. So sine inverse of 0 is 0. Okay, this last one, tan inverse of negative 1. So tan inverse of negative 1, okay, I should say this would be tan inverse of, and we need a ratio, right? This would be the ratio of negative 1 over 1. Well, for tan inverse, okay, if the ratio is negative, tan inverse, I'm restricted to only the first quadrant, but I'm only going to use this first quadrant if this ratio is positive. It's not, it's negative. So I'm going to rotate down into this fourth quadrant when the ratio is negative. So I'm going to rotate down here because my ratio is negative, okay? From this ratio, I know my y is going to be negative 1 and my x is going to be 1. So this is going to be negative 1 because I'm going down and I'm going to the right. To get to this point, I'm going right and down. The y would be negative 1 and the x would be 1. We should recognize those for the legs, right? 1 and negative 1. This would have to be the square root of 2. This reference angle that we get from the triangle would have to be pi over 4. And then what's the rotation that I have to do? Well, I'd have to rotate clockwise in this direction. So what would the answer to be to this? Well, this would be negative pi over 4. Hopefully you're catching on to this, okay? So sine, you're limited to the first quadrant and the fourth quadrant. First quadrant, positive angle. Fourth quadrant, negative angle. Tan inverse, you're limited to the first quadrant and the fourth quadrant. rotate into the first quadrant with a positive angle if the ratio is positive, rotate into the fourth quadrant if the ratio is negative, and that would be a negative angle. Cosine inverse is the first and the second quadrant. You rotate into the first quadrant if the ratio is positive. You rotate into the second quadrant if the ratio is negative. And those are the only three inverse trig functions we need to know, okay? All right, let's go to the next problem. Okay, for this next example, we want to find the exact value of these two expressions, okay? So I want to point out, okay, we work inside out, okay? So right here, we're starting with, this is a ratio and it's a negative ratio, right? And we're putting that negative ratio into cosine inverse. When we do that, we're going to get an angle out. So for this part right here, that represents some angle, okay? And then we're going to take that angle that we get and put it into sine, and then we're going to get out a ratio, okay? So we're going to start with a ratio, putting it into an inverse trig function, which will give us an angle, putting that angle into a trig function, and we're going to get out a ratio, okay? So let's start with, okay, so cosine inverse, let's start by figuring out what is cosine inverse of negative square root of 3 over 2. Okay, so I'm doing cosine inverse. So I'm going to draw a diagram. Okay, and because it's cosine inverse, I'm either going to be in this first quadrant if the ratio is positive, or I'm going to be in this quadrant, the second quadrant, if the ratio is negative. My ratio is negative. That means I'm going to have to rotate into the second quadrant to get it, right? Because over here is where the cosine ratio is going to be negative in the second quadrant. Okay, so from this ratio, and basically what I have to do is I have to figure this angle out, right? Okay, and so I know I have an angle here, or a right angle here. I know my x is negative square root of 3 from the ratio. I know that's true. I know my r is 2. I know this would have to be 1. And then because of the orientation of these sides, I know this angle of the triangle, which is also called the reference angle, is pi over 6, right? Because opposite 1 is always pi over 6, and opposite square root of 3 is always pi over 3. Okay, so what's this angle of rotation? Well, this would be 5 pi over 6, right? Which means cosine inverse of negative square root of 3 over 2 is 5 pi over 6. Okay, so this is equal to sine of, okay, so what was cosine inverse of negative square root of 3 over 2? It was 5 pi over 6. Okay, now you could, okay, now we have to figure out sine of 5 pi over 6, right? We have to figure out sine of 5 pi over 6. Okay, now for sine of 5 pi over 6, I could draw a diagram, right? But I don't have to, because I have a diagram already for the angle of 5 pi over 6. It's this one right here again, right? Okay, so because, and here's what's weird is this is, okay, this ratio is going to give you an angle, right? And that angle is going to be in this diagram, okay? And because that angle's in this diagram, you can use this diagram a second time to figure this one out, okay? Would it be wrong if you did a whole new diagram for this problem right here? No, not at all. It's just we can reuse stuff if we have to, okay? So sine of 5 pi over 6, you would just draw the same diagram, okay? And so sine is y over r, so our y is 1 and our r is 2. So the answer to this is 1/2, okay? Now I'm going to tell you, you can use this diagram twice like we just did if you're starting with a ratio, putting it into an inverse trig function, and then putting that into a regular trig function, okay? Like we could have found tan also, right? Because tan would have been this one over this one. It just would have changed this ratio, okay? This angle would not change, okay? Okay, so let's do this next one. Okay, so cosine, okay, of tan inverse of negative 1/5. Okay, so I know I'm doing tan inverse, okay, and I know that my my ratio is negative, so I'm going to draw my diagram. And for this one, for tan inverse, I have to rotate into the first quadrant. It will do me no good to rotate in the second quadrant because in the first and the, well, I take that back. I take that back. okay? For tan inverse, what we want to do is we want to rotate either into this first quadrant or the fourth quadrant. And it has to do with the graph of tan inverse, okay? That's why we can't use this quadrant. It's because we weren't using this quadrant in the graph of tan inverse, okay? So tan inverse is negative. We will rotate into the first quadrant if this ratio is positive. It's not, it's negative. Our ratio is negative, right? So we're gonna have to rotate into the fourth quadrant, okay? And what do I know about this? Well, because this ratio is y over x, I know my y is -1, and I also know my x is 5, positive 5, right? What I don't know is the angle of rotation, okay? And these are not sides of a special right triangle, right? So I can just call this angle theta, okay? All right? And I can find this, all right? This is r. And I know it has to be positive. How can I find r? Well, this is a right triangle, so I could use Pythagorean theorem to figure out this r. Okay, so I know my x is 5, so I'm going to take 5 squared plus -1 squared, and that's going to equal r squared. Okay, 5 squared is 25. -1 squared is 1 is equal to r squared. That'd be 26 is equal to r squared. Square root both sides, and it has to be positive, so we're just going to write r is equal to the square root of 26. Okay, now that's our radius, right? Okay, so we're going to use this angle theta to determine the angle of rotation. Okay, we know this is the square root of 26. Okay, so when we do this ratio, tan inverse of -1/5, we actually never have to find this angle theta. Okay, and here's why. We're going to just call it theta. All right, and so this is going to be cosine of, okay, so whatever this ratio is, we're calling it theta. Okay, we're calling this angle theta. So then we're going to find cosine of this angle theta. Okay, well, what is cosine of angle theta? Well, it doesn't matter what it is. Cosine is x over r, right? So our x is 5 for this angle theta, and our radius is the square root of 26. So we don't need another diagram is what my point is, okay? Just like before, we don't need a second diagram. So this would be 5 over the square root of 26. Okay, now that's unsimplified, so we need to know how to simplify it, right? We multiply the top and bottom by the square root of 26. So this would be equivalent to 5 square roots of 26 over the square root of 26 times the square root of 26, which is just 26. And that's our answer for this. Okay? All right, let's go to our next example. Okay, so from this, okay, I know that theta is equal to cosine inverse of x. And then from that, I want to be able to find sine theta, cosine theta, tan theta, secant theta, cosecant theta, and cotangent theta. Okay. Now, what this means is theta, our angle theta, is equal to cosine inverse of, and remember when we do inverse trig functions, this needs to be a ratio, right? Well, how do you write x as a ratio? Well, it's x over 1. X over 1 is a ratio, okay? Now, I know my x coordinate is x and my radius is 1, so I can draw a diagram. Now, where do you draw the diagram? Well, you don't know if this ratio is positive or negative, so let's just draw the easiest example, and that would just be in the first quadrant, okay? And that will actually take care of everything, okay? You don't even really have to worry about it. So we're going to put it into the first quadrant. Okay, so from my ratio, I know this is, my x is x. I know my r is 1. This is the angle theta that we're talking about right here. Okay, and so I need to find this, right? Well, what is this? Well, that's my y. How can I find it? Okay, what is y equal to, right? Okay, so y is equal to, so x squared plus y squared is equal to 1 squared. We're going to use Pythagorean theorem again. Okay, so x squared plus y squared is equal to 1, which means y squared is equal to 1 minus x squared. Okay, and because we drew it in the first quadrant, okay, we're going to make y, we're going to square root both sides, and y becomes the square root of 1 minus x squared. Okay, so this is the square root of 1 minus x squared. So we want to write these all in terms of x. Okay, So what is sine of angle theta? Sine of angle theta would be this y coordinate, which is the square root of 1 minus x squared, over the radius, which is 1. Okay, that would simplify to become just the square root of 1 minus x squared. Okay, cosine theta is, cosine of angle theta would be x over 1, or simply x. Tan theta is y over x. So that would be the square root of 1 minus x squared over x. Cosecant theta is equal to the reciprocal of sine. So it's going to be r over y. So that'd be 1 over the square root of 1 minus x squared. Okay, don't worry about, I want you to simplify this if it was numbers. Okay, if it's not numbers, don't worry about simplifying. Okay, just leave it like that and it's fine. It's fine. Okay, secant theta is the reciprocal of cosine. So cosine is x over 1. So this one's going to be 1 over x. Cotangent theta, right? Because I asked you for all 6 of them. Okay, cotangent theta is the reciprocal of tan. Well, tan is y over x. So this one's going to be x over y, right? So it's going to be x over the square root of 1 minus x squared. And if, okay, once again, if this is not an, if this square root is not a number, okay, like this is, it's an algebraic expression, just leave it. You don't have to simplify it. Okay, and that's the that's the 6 trig functions based on theta equaling cosine inverse of x. Okay. All right, that's inverse trig functions. Okay, so let me just make sure. Okay, one of the big things that I want you to understand is, okay, if I give you sine inverse, find sine. The very most important thing of all of this is example 1, and where we did those 6 problems. Okay, that is the most important thing. Okay, so you just got to remember your restrictions. Okay, you have to recall. Okay, for sine inverse, we are either going to be in the first quadrant if the ratio is positive. We're going to be in the fourth quadrant if the ratio is negative. For cosine inverse, we're going to be in the first quadrant if the ratio is positive. We're going to be in the second quadrant if the ratio is negative. For tan inverse, we're going to be in the first quadrant if the ratio is positive, and we're going to be in the fourth quadrant if the ratio is negative. That is the take home thing. That is the most important thing. Like, you know where to draw your diagram, your picture, okay, to answer the questions. Okay, guys, that's it for inverse trig functions. Okay, we're going to be practicing this over the next few days, and we're going to start doing trig identities, okay, which is really important for calculus because it simplifies problems, okay? We need to be able to do trig identities in order to simplify things, okay, and make things easier on us in calculus, to be honest, okay? All right, that's it, guys. Let me get that assignment sheet and we'll fill that out. Okay, so for today, what I want you to do is worksheet TEI 1. Okay, and that's just, you're going to find a lot of inverse trig functions, and just again, it's important, like, you know which quadrant to put these in. Okay, that's the big deal. Okay, and it's okay to go back to your notes and go, oh, I have to put in this quadrant, oh, I have to put in this quadrant, and then the more you do, the better you get at it. Okay, just one of those things that you gotta practice this stuff. Okay, all right, okay, so that's it for today. This is okay. I'm just going to forewarn you. Okay, some of these lessons are going to take some time to explain. Okay, they are going to take some time. Okay, so we got to put the time in right now. Okay, so it pays off later on. Okay, remember, this is an investment. You're not getting a paycheck right now. Like, you're going to get paid down the way. All right, and you just got to realize, like, this is going to make things easier on you. Okay. All right, guys, you guys take care. Have a great day. Have a great weekend. Bye-bye.